This case study concerns a system in Spain, SANCUGAT de Valle, which is a little bit to the northwest of Barcelona, and it is part of the Horizon 2020 GeoFit project. You can find more information on the website geofit-project.eu. It is a retrofitting system. GeoFit was concerned with retrofitting of existing buildings, and it has a geothermal system, a heat pump and borehole heat exchangers to reduce the environmental and carbon footprint of the system. There are gas-fired boilers on site, and these have been integrated. The heat pump has been integrated with the existing heating system. So the system, it's a primary school with different classrooms and a gymnasium. There's also a kindergarten available, and like I said, a gymnasium, a sport pavilion. There is also some administration, and in the administration rooms, an additional cooling system was installed because there was no cooling so far, and that would improve the comfort and allow one of the partners to test low invasive installation of a cooling system. Past renovation works were already done. We have 27 of photovoltaic panels, kilowatts. We have a retrofitting of the facade, so better insulation. Windows were replaced and LED lighting was installed. The main heat supply is by condensing boilers with a temperature of 65 degrees C, so we need high temperature for the heating system, and the peak load is 192 kilowatts with about 145 megawatt hours of heating. The heat demand curve calculated for this system is shown on the right, and again we can see that there are many hours with a load lower than the maximum peak of 190 kilowatts. So a hybrid heat pump system was designed with the boilers as backup. A high temperature heat pump was delivered to site, made by Uxner, one of the project partners. It can deliver 80 degrees to the flow side of the system. And at the end of the day, we found that with a little bit under 100 kilowatts of thermal capacity, it can deliver 95% of all heating energy. The COP of the heat pump, because it's a very high temperature heat pump, will be around 3.5, still pretty good. And cooling for the offices is added, but that is only 2.2 megawatt hours. The calculations for the borehole heat exchanger system were done with the standard program Earth Energy Designer, and you can see all the parameters that we used in the calculations in the table. The end depth was around 160 meters, 12 boreholes could be fitted on the site with a spacing of 10 meters between the boreholes. The temperature graph on the right shows the solution of Earth Energy Designer, where you can see the temperature decline over the years, which evens out after a while, so the system can operate for a much longer period, in fact. And you can also see that there is not a big difference between the base load, the black line, and the peak load, the red line. So the peak load does not overshadow the design in this case. We did a sensitivity analysis on the design, and we varied parameters like average ground temperature, thermal conductivity of the soil, the base load heating, distance between the boreholes, borehole diameter, borehole thermal conductivity, heat capacity of the soil, and base load cooling. And here they are ordered on significance. You can see that especially the average ground temperature, the thermal conductivity of the soil, and the heating are the most important parameters affecting the design. Obviously, doing the borehole, the drilling on site, and also testing on site, the average ground temperature and ground thermal conductivity have been established with a high degree of confidence. The site available for drilling is indicated here, and the actual drilling operation by a Spanish driller, CDP, Catalunya de Perforaciones, was shown on the right. Here, a layout of the whole system and the integration of the heat pump with the condensing boilers. We won't talk too much about that, but there is a BMS by Trent, and the energy control of the heat pumps to the collective buffer tank is by Belimo energy valves. Here you can see the heat pump delivered to site. It's one fairly big unit, and the Belimo energy valves installed in the pipework together with some circulation pumps on the far right. The whole GeoFit project, and especially this case study, were pretty successful. You can see a list of all the partners here and a nice picture of all the people at the SANCUGAT demo site.